We are doing 1.6, which is exponent laws. And again, this may feel like review to you. So we'll try or start with a few examples. We're going to be doing the product rule, the quotient rule, and the zero exponent rule. Do those sound familiar? Okay, good. So let's start off first with the product rule. So let's say, for example, we have x to the power of m times x to the power of n. Everybody know the rule? What do I do with the exponents? If I have the same base at the bottom, what do I do at the top? Yeah.
You do x to the power of m plus n.
Excellent. X to the power of m plus n. So that's the first rule. I guess I don't need to write example there. This just is the rule. If you have two powers that have the same base, when I say base, I'm referring to this part, then I can just rewrite the base in the answer, and I simply add the exponents that are up top. So let's actually use some values to help us to understand this. If I had negative 2 to the power, well, just that, times negative 2 to the 5, can you tell me? You can just call it out if you want. Negative 2 to the power of 6. Is everybody good with that? So in this first one, it doesn't say anything at the top. If it doesn't say anything, what is that? It's a 1. We all know that, right? So if it doesn't have an exponent written, I could write anything as a power with an exponent. I just make the exponent 1. Okay, so I had a feeling that you might be okay with that. So we know those, but how about when I make it a little more interesting? So if I have 2 to the a plus 2 times 2 to the 4, don't call this one out. I want you to actually either write this down or think of what it would be. But when I have something that's set up a little bit differently like this, are we still okay with how to go about this? Pardon? Well, that's okay. It's okay, no big deal. So we keep the same base, so we rewrite the 2, right? So that's the first thing. I always check to see, do they have the same base? They do. And then what do we do to the exponents at the top? We add them. So if I have a plus 2 plus 4, which are the parts that we can actually add together? The 2 and the 4. So I get a plus 6. Good. We're all good with that? Okay, because it can look a little intimidating to see variables or letters and numbers in the exponent. There's a lot of stuff going on there. Okay, so let's try another one that has a lot of stuff going on. Let's say we have 3 to the ab plus 1 times 3 to the ab minus 3. And I want you to come up with what that would simplify to. So you know how sometimes they say simplify or solve? We can't really solve because we have variables in there, but we can simplify it or shrink it down. Okay, just has everyone had a chance to, we're all good? Okay, yeah.
It would be 2ab plus small 3 to the 2.
Yeah, so the base stays the same, and then here we have an AB plus another AB. Everybody good with that? It's like you're counting up how many ABs we have. So we have 2AB minus 2. Is everybody okay with that? Don't you love this stuff? We're not, okay, it's okay. You can tolerate it? Okay, that's good enough. I'm happy with that. Okay. Oh, I think we're ready for this. I was looking at this next one and thinking, really, should we? But yeah, we will. 2 to the 5 minus 2 to the 3 times 2 equals. Don't call it out. Just look at this and make sure that you know what's going on, because there's a couple of things, a couple of operations. What are and aren't you allowed to do? Okay. Where should we start?
I'm pretty sure it's
2 to the 2? Okay.
Is it 2 to the power of 5 minus 2 to the power of 4?
Okay, I'm going to rewrite that. We're on the right track. 2 to the power of 5 minus, because we can't use our power or our exponent laws when we have a minus sign in between, right? So we're sort of stuck. Like we can't add them together or whatever. But we can add this part. That would be 2 to the 4. So we're getting there. Although we can't apply our exponent laws, do you know what 2 to the 5 is? This is one of those that if you don't know yet, we've got to know. Let's actually, let's first go through, like we know it starts with 2, then what's 2 squared? 4. What's 2 cubed? What's 2 to the 4? So then what do you think 2 to the 5 is? So this is 32 minus what's 2 to the 4 again? So after all that, what's our answer? Yeah, do you see that after all that, the answer just works out to 16? So here's the tricky part. If you have a plus or a minus sign in between them, even if they have the same base, yeah, we have to bring it down to a number. We can't apply exponent laws in that situation. Yes? In the first step, you can, and you'd get the same end result. Good question. Good? So far, so good? Okay, so then I feel like based on that, you're all going to know this. If I have x to the m over x to the n, what is that the same thing as? Or what am I allowed to do with that? We call this the quotient rule. Yep. Not m times n, but if when they were what do we do with m minus n? So this in this box is called the quotient rule. You don't really need to know what they're called, but I do need you to know what to do with them. So kind of makes sense. Like when you're multiplying something with the same base, we add the exponents. When you're dividing them, we subtract the exponents as long as the base is the same. Yes?
So there's a question where it's like 5 to the power 7 over 5 to the power 3 times 5 to the power 4.
Mm-hmm.
So you first to the bottom. So
Hang on, we're not there yet. I'm going to keep teaching this and then we'll get to that.
But my question was if it goes to a negative, so it's like 5 to the power.
Again, we're going to get to that in just a second. So just hold on. So if, for example, we have 10 to the power of 3 over 10 to the power of 6, according to this law, or this rule, the quotient rule, what do we get in this case? 10 to the power of negative 3. Everybody good with that? Because what we did is 3, that was at the top, minus 6, right? And then here's the other thing. We don't like to have a negative exponent. So how can I rewrite this to make that negative 3 a positive? Yeah, Ruby? No, we can't move that negative in front. I'm actually wondering if you did this or not because I'm not sure. No? What's the rule? How do we make it positive? Good. Yes, we turn this into a fraction. We take the reciprocal of the base. Do we all remember what a reciprocal is? Yeah, so if the base is 10, then I change it to 1 over 10. And when I do that, the exponent stays with that 10 or with that base, but it magically becomes positive. So it's 1 over 10 to the 3. Does that make sense to everybody? And you're not going to have calculators for this, but do we know what 10 to the 3 is? It's 1,000. So a better way for me to say this. So whenever we can do this without a calculator, we want to change it to a number. But if it's something like 5 to the power of 9, we don't know that. So you can leave it that way. Question?
Could you also just do it by solving like 10 to the power of 3 and then 10 to the power of 6?
Yep. Yeah, but we're learning the exponent laws today. So we're going to do it using the exponent law so we can practice that. Good? Okay, let's look at when we make it a little more complicated. Not a lot, but just a little bit, because we'll go step by step, a little bit at a time. Over a to the m minus 3. I'm going to go through this first one with you. First of all, what's the base? What's the base going to be in the answer? It's going to be an a. At the top, we have m plus 1. What do I do with the m minus 3? Yeah, if I'm going to subtract something with two terms, like m minus 3, I need to make sure that there's brackets there. Why do I need to make sure that there's brackets there? And also, what effect do the brackets have on this negative? Like, what do I need to do with that negative if I want to take the brackets away?
If there were no brackets, it would be 1 minus m.
Yeah, but this time I need to, and again, I don't know if you know this word, but I need to distribute this negative sign here and here. Actually, I'm going to get fancy on you and use different colors. We're going to do this and this, and the reason I'm doing that is so you can clearly see what impact this has. So we have m plus 1, and you see here I would end up with minus m, and this is going to become plus 3. So do you see that without the brackets, that minus 3 would remain a minus 3? So it has a really significant impact. So we need to make sure that we put those brackets there. And then the rest of this is like collecting like terms, which you learned about when you learned about algebra, but maybe you don't quite remember, and or we'll just build in review. But what are the like terms in the exponent up here? Yeah, if we have an m minus m, what happens to them? They're just gone. So that's nice when that happens because it makes life easier for us. So then here we have 1, but it's plus 3, right? So what do we get? A to the power of? After all that, it's just a to the power of 4. Good? So it's like tiny nitpicky little details. The fact that over here, we need to distribute that negative, so we need to make sure that we remember to put those brackets there. Does that make sense so far? Okay, so let's do another one. Let's combine a few things. So let's say we have 5 to the negative 4 times 5 to the 3 all over 5 to the 7. Here's the thing. Students often think like, oh, this is getting difficult because it will get longer than this. There will be more stuff going on. But if we just ignore the bottom and pretend it's not even there, and I just gave you the top, so breaking it down and taking a step-by-step approach makes it easier. So I'm going to rewrite this and say it's just 5 to the 7 at the bottom. We're going to ignore that. Can somebody tell me what we would get at the top when we apply the exponent law that works for this? Yeah. 5 to the negative 1. Does everybody agree? So all we've done is the stuff at the top. And now do you see that this part is looking a lot easier? It's just like the ones we just finished doing. So I'm going to carry on with that down here. What do I do when I go to simplify this? 5 to the, what should I do with the exponents? Well, so it would be negative 1, and then we're going to subtract that 7. Does everybody see where I got that from? So then the next question is, what is negative 1 minus 7? 5 to the negative 8, and we just talked about how we don't like leaving it that way. What's a better way that I can rewrite that?
1 over 5 to 5/8.
Yeah, 1 over 5 to the power of positive 8. So this is the best way that we could simplify and give our answer. Make sense?
You
So-
don't have to figure out 5 to the power.
Well, because we're assuming in grade 9 that we're not going to use calculators, again, if you really feel like you need one, we can talk about that. Just have a talk with me about it, and we'll figure that out. But we'd have to sit there and go 5 times 5 is 25, times 5 is 125, and times 5 again. We'd have to sit there and calculate this all. That would take up all of your time, and then you wouldn't be learning the concept. You'd be working on your multiplication of large numbers. Does that make sense? So yeah, if it's an unreasonable number like this, you can just leave it this way. You could give your answer this way.
If it is a smaller number and you can do it, should we just write the number answer?
For sure. If you ever are able to do it, then definitely go ahead and do it. But if it's a large number, then you don't need to worry about it. Good? Again, keeping that sort of flexible approach to things. Don't stress about that stuff too much. I want you to learn the concepts. That's what we're trying to get out of this. Good? Okay, and then this part, I'm wondering, I think you probably maybe have done this before, but I'm not sure. If you have x to the power of 0, what is that? Yeah. What if I had, for example, I don't know, 2,352 to the power of 0, what is that? So basically, anything to the power of 0 is always going to be equal to 1. So if, let's say, we had 4,321 to the power of x and it's equal to 1, and it says to solve for x, what must x be equal to? I'll see why we did this. It messes with your mind. It must be 0. Do we get that? So it's sort of looking at it from the opposite perspective, but to make sense of this, if this white part, if it's to the power of x and it's equal to 1, then the x value has to be 0. Good? Yes, question?
Why is it that when you put something to the power of 0, it makes it 1?
Okay, that is a really good question, and this is so not going to be satisfying, but you're not going to know until grade 12, because the thing that will help you to understand this, I feel like this is true of most concepts. To understand it, you have to go full circle and to be able to do the opposite of it, and doing the opposite of it involves something called logarithms. Doesn't it sound awful? It's not that awful. We shorten it and just call it logs. And this thing has a horrible reputation that grade 12s dread, but it's not that bad. When you get there, you're going to enjoy it, and it's not going to be too bad. But that is what will help you to understand the reason for this. But for now, you're just going to have to accept that that's how it is. And I am not a fan of memorizing, but we're just going to, I guess, memorize it or know this to be true for now. And then know that eventually, when you're able to go full circle, the solution to that will appear. Good? What's 0 to the power of 0? It's undefined. It's an odd one. It's an unusual one. So I just thought that maybe we should mention that. 0 to the power of 0, we would say, is undefined. Yes. Oh.
Actually, a question. So, for the ones like to the power of over, like so it's like 11 to the power of 3 to 11 to the power of 5, 11 to the power of 0. But we're talking about 11.
Wait, what? I'll come look at it because
I just understand how it would become a negative or positive.
Okay, I'll come look at it. Good? Okay, so here's what I want you to work on. You're going to do for numbers 1 to 9. Everybody know what I mean by this now? This OL? Odd letters means like A, C, E, G. So you do the first one and then you skip so that you're only doing half of them for each question. Does that make sense?